This video is part of a series which introduce a new advanced analysis capability for frequency domain response and fatigue. There are 8 videos, of which this is the first one explaining the concept. I spent most of my working life involved in and around the topic of frequency domain fatigue, especially when finite element methods are used to generate the stresses. We were told 20 to 30 years ago that these techniques would quickly become widespread. But severe limitations, firstly in terms of computing power, but more recently in terms of the technical methods available, have severely hindered widespread use of these tools. CAEfatigue vibration is a game changer. By removing most of these technical restrictions, real-world design problems can now be handled. CAEfatigue vibration is a random response post-processor, which works with mixed random and deterministic loading sources in a way which is not possible with existing products. The starting point is a Nastran-generated stress transfer function OP2 file, as well as a set of analysis instructions given in a text input control file. The output is a Patran neutral or CSV file, or both. Frequency domain techniques are widely needed in industry. This is a summary of some of the general industries where PSD-type loadings would be routinely specified. And within each of these broad industry segments, we can see there are subdivisions of these where PSD loads are, or would be, an attractive means of defining loading conditions. So let's ask the question, what is the frequency domain? For this, we can begin with Fourier series from the early 1800s. Basically, Fourier series methods assume that the time-based signal can be transformed into a form which is a function of frequency as shown. In general, this is a much more versatile form of showing the loads. Of course, there are some restrictions and assumptions, and unfortunately these have been allowed to severely restrict the use of the techniques for structural analysis and fatigue life calculations. One of the reasons why the frequency domain is such a powerful analysis environment is because it allows us to define structural behavior using what we can call system transfer functions. And unlike working in the time domain, these system transfer functions are properties of the structure and not the loading. The process of identifying these system transfer functions can be reduced to the relationship between sine waves of load applied to the structure and the resultant sine waves of response. So for the last 50 years, since the introduction of powerful finite element solvers like Nastran, we have been enticed with the possibility of very powerful frequency domain stress and fatigue solutions. Such first generation solvers do exist today, but they are severely limited in terms of model sizes that can be analysed, the type of fatigue solutions that can be employed, the form of loads that can be applied, and finally, they are typically restricted to single input systems. The goal of the CAEfatigue vibration product is to substantially reduce these restrictions. In terms of both stress response and fatigue life, we can easily see why working in the frequency domain should be such a powerful approach. This is because once the structural response is available in the form of a power spectral density or PSD, the subsequent behavior, including fatigue life, can be completely defined using 4 spectral moments, M0, M1, M2 and M4 as shown here. This is the central proposition which makes the frequency domain approach so attractive. The overall approach then follows the classic flow where materials, loading and stress information is needed as input, with stress response and fatigue life in different forms being the output. The red stars here show where major improvements to the first generation approach have been made in CAEfatigue vibration product. So CAEfatigue vibration is a new second generation technology developed from the ground up, with no reliance on first generation algorithms. It's designed as a super efficient vertical application sitting on top of a stress solver such as Nastran. Because of a novel running sum approach built into the design, stress results file size limitations of existing solvers have been removed. Numerous new algorithms are included. Post-processing is possible in any package that accepts Patran neutral files. Here we see a number of response quantities plotted by Patran. Primary response, derived response and fatigue results are all available in this form. The current release, Release 1 of the CAEfatigue vibration product, includes 3 modules. These do random response analysis. This is where you have a single random input, no deterministic loads and no mean offsets. The first release also has a module for random only fatigue, and the third module is full fatigue including deterministic inputs. Release 2 of the product, which should be available within a couple of months, also includes multiple random loads. The CAEfatigue vibration product is currently available from any of these 3 companies. Please check our website www.caefatigue.com for updates to this list.